Here are some solutions to exercises on limits and continuity. This time we're going to answer odd numbered exercises. So the following are the problems. We are to evaluate the following limits. Notice that for the following odd numbered problems, 1, 3, 5, and 7, since direct substitution on the function will give us 0 over 0, then L'Hopital's rule can be applied to solve for their limits. However, since we had not yet discussed topic 2, which is on derivatives of functions, then we're going to make use of algebra to solve the following problems. So this time we're going to solve for the limit of the cube root of x cubed minus 8 all over x minus 2 as x approaches 2. Recall the following limit theorem, which says that if f and g are two functions such that f of x is equal to g of x, for all this time x not equal to a, then if the limit of g of x as x approaches a exists, then the limit of f of x as x approaches a also exists. Moreover, the limit of f of x as x approaches a is equal to the limit of g of x as x approaches a. So what we're going to do now is to rewrite this function into an equivalent function. And we can do that by this one. We try to factor x cubed minus 8 inside, and then we can divide out x minus 2 with one of its factors, like this. So we have here, say we write now the cube root of x cubed minus 8 over x minus 2. It's the same as the cube root of x minus 2 times x squared plus 2x plus 4 all over x minus 2. And since x minus 2 and x minus 2 can be cancelled out because x here is not equal to 2, it's just approaching 2, so you can divide it out. That now becomes the cube root of x squared plus 2x plus 4. So this now becomes the limit of, so as x approaches 2, this function can now be rewritten as the cube root of x squared plus 2x plus 4. So the limit of this as x approaches 2 is the cube root of, you replace x there by 2, so you have 2 squared plus 2 times 2 plus 4, which is equal to the cube root of, that's 4 plus 4 plus 4. So the answer is the cube root of 12. So next we go to, this time we're going to solve for the limit of 2x squared minus x minus 3 all over x cubed plus 2x squared plus 6x plus 5 as x approaches minus 1. Now what we're going to do is to make use still of the limit theorem number 10, that is, we're going to find a function here which will be equivalent to this function. It's 1 equivalent to this. And then that's what we're going to take the limit of. So here we notice the 2x squared minus x minus 3 is factorable. Meaning to say the numerator is factorable. And as for the denominator, although it's factor, it's not obvious. So what we're going to do is to find factors which should be, or in one of the factors would at least be similar to the factor in the numerator. So let's take a look at this. We write this one as follows. That is, we try to rewrite. So we write 2x squared minus x minus 3 all over x cubed plus 2x squared plus 6x plus 5. The numerator can be factored as 2x minus 3. It's 2x minus 3 times x plus 1. Because 2x times x will give us 2x squared minus 3x, and then plus 2x will give us minus x, minus 3 times positive 1 will give us minus 3. So on the other hand, this one here, your denominator, what we can do is to divide it out by, let's see, the factor x plus 1. So we have x cubed plus 2x squared plus 6x plus 5 divided by, we have x plus 1. We do this to find the other factor. So we can, this one is x cubed divided by x will give us x squared. So you have x squared times x will give us x cubed. X squared times 1, so you have plus x squared. Then minus, so this is 0, this is plus x squared. And we have plus 6x. Then again divide it by x, so you will have plus x. X times x will give us x squared. And x times 1 will give us x. So we have plus x here. Then again subtract. So what is left here is 5x. Then you have plus 5. If we divide the entire thing by x plus 1, we'll get plus. So you have 5 because you have 5x here. Then 5 times 1, so you have plus 5. Notice that this is equal to 0 here. So meaning to say, the factors of x cubed plus 2x squared plus 6x plus 5 is equal to, you have x plus 1, and the other factor is x squared plus x plus 5. And then again, because x is not equal to negative 1, it's just approaching negative 1, we have x is not equal to minus 1, so we can divide this out. And this function here is now equal to 2x minus 3 all over x squared plus x plus 5. Notice that it is easier to have this side solution and just simply plug in that equivalent function, that is the limit now of, instead of rewriting this, you have limit of 2x minus 3 all over x squared plus x plus 5 as x approaches minus 1. This is true because this one is equivalent to this function as long as x is not equal to negative 1. It's just approaching negative 1. So the value of this will now be 2 times negative 1 plus negative 3 all over negative 1 squared plus negative 1 plus 5, which is negative 2 minus, we have this is 3 all over 1, then minus 1 plus 5. which is equal to negative 5 over positive 5, which is equal to negative 1. Meaning to say the limit of this function here is equal to negative 1. So we now go to the next exercise. That is exercise 5. This one is easier to rewrite because we know that we can factor 1 minus x squared. So we can this time rewrite x minus 1 all over 1 minus x squared as x minus 1 over 1 minus x times 1 plus x. Now to have the same factors, we can again rewrite x minus 1 into the negative of, you can place 1 before x, so 1, this becomes minus x, because negative of negative becomes plus here, so 1 minus x, all over 1 minus x times 1 plus x. From here, again, because x is simply approaching 1, so x is not equal to 1, you can divide out 1 minus x with 1 minus x. So you're left with negative 1 over 1 plus x. This is 1. So from here, you have the limit of, this is equivalent to the negative of 1 over 1 plus x as x approaches 1. And we can now replace x with 1, so that's equal to negative 1 over 1. Okay, this one is plus 1, so x is plus 1. So plus 1, so the result is negative 1 over 2. So we now solve for the next problem. Let's go to number 7. So for number 7, we can simplify again this function by multiplying the value 1. And 1 can be in many different forms. This time we take it as follows. It is, we can rewrite this time, rewrite 1 minus x over the square root of 12 minus 3x minus 3, okay, as 1 minus x all over square root of 12 minus 3x minus 3 by multiplying it with 1, which is of the form square root of 12 minus 3x plus 3, okay, all over, you have square root of 12, oh sorry, this is supposed to be square root, so we have square root of, it's not a plan, okay, yan. So that's square root of 12 minus 3x, then plus 3, plus, let me just erase that one para hindi ito. Okay, so that should be square root. Oops, square root then. Okay. It doesn't look good. Maybe it's not an olive. That should be square root. Yeah. So this is now equal to 1 minus x times, we have the quantity square root of 12 minus 3x plus 3 all over, when you multiply this quantity, you can recall the following formula, just in case you forget. if we have u minus v times u plus v, that's the same as u squared minus v squared. So in this case, our u is 12 minus 3x, and our v is, we have 3. So if we have u minus v times u plus v, it should give us u squared minus v squared. I mean to say, this is the same as the square root of 12 minus 3x squared minus, from here, you have 3 squared. So that's now equal to 1 minus x times the square root of quantity, the square root of 12 minus 3x plus 3 all over, this is 12 minus 3x, get rid of the squared and 2 there, so minus 9. But that is the same as 1 minus x square root of, we have 12 minus 3x quantity plus 3. We have 12 minus 3x. 12 minus 3x minus 9 will give us 3 minus 3x. So all over 3 minus 3x. Okay, 3 minus 3x. Let me erase this one here, but we can continue. So that is equal to 1 minus x times the quantity square root of 12 minus 3x plus 3 all over, you can factor out 3. So 3 times 1 minus, this one is x. Then, again, because x is not equal to 1, it's just approaching 1, you can divide out 1 minus x here by 1 minus x. So what is left here is that you can now simply take the limit of this one is square root of 12 minus 3x plus 3 all over, what is left here is 3 as x approaches 1. And because x is approaching 1, you will have, can replace x by 1, so you have 12 minus 3 times 1, then plus 3 all over 3, which is the same as the square root of 12 minus 3 plus 3 all over 3. But square root of 12 minus 3 will give us square root of 9, square root of 9, plus 3 all over 3, which is the same as square root of 9 is 3, so you have 3 plus 3 all over 3, which is equal to 6 over 3, meaning to say that's equal to 2. So the limit of this is actually equal to, so the limit of that's equal to. Then we go to the last exercise for the odd numbered problem, which is the square root of p minus 3 all over square root of 1 plus square root of p minus, the limit of the square root of p minus 3 all over square root of 1 plus square root of p minus 2 as p approaches negative 2. Now, we have here a hint that the limit of a continuous function at the point is just its value there. Notice that because this is still actually defined in terms of complex numbers, the square root of negative 2 and square root of negative 2 here. So if we simply substitute the value, we come up with square root of minus 2 minus 3 all over square root of the square root of minus 2 plus 1 minus 2 here. Okay, but that is the same saying that because you can actually rewrite square root of negative 2 into square root of 2i. Okay, so square root of 2i, so you can factor out the I there, and then minus 3 is the same as I times I squared times 3. because I times I squared is equal to -1. That is if you make use of the definition of the complex number, that is your, if you remember, a complex number says that for complex number we have a plus bi, where a, b are element of your real number and your I squared is actually equal to -1. So this means element. Okay? That's for your complex number. So, but we can also solve this in a different way, just like what we did earlier. That is, we can rewrite this. We come up with the same answer actually, although it would look different, but it's simply the same. So we can rewrite square root of p minus 3 all over square root of 1 plus square root of p minus 2. That is the same as square root of p minus 3 all over square root of 1 plus square root of p. You have minus 2 times multiplied by 1. Oh, and 1 is of the form 1 plus square root of p plus 2 all over the square root of 1 plus square root of p plus 2. So that should give us square root of p minus 3 times, you have square root of 1 plus square root of p plus 2. This is one quantity here, all over, again, if you remember can recall your u squared minus v squared is equal to u minus v times u plus v. So this is the same as in the denominator you have square root of 1 plus square root of p minus, then you have squared, then minus 2 squared. So this should give us square root of square root of p, then minus 3 times square root of 1 plus square root of p plus 2 all over, can get rid of the radical sign as well as 2 there, so 1 plus square root of p, okay, this is minus 2 squared, so minus 4, but 1 plus square root of p minus 4 will give us square root of p minus 3. So this now, let me erase this one again here so that we can continue here. Okay. Set 1. So this is the same as square root of p minus 3 times 1 plus, that's the square root of 1 plus square root of p plus 2 all over, this is square root of p, then is minus 4, right? And plus 1, so that's minus 3. So again, we can divide this out by this. So what is left there is the limit now of the square root of 1 plus square root of p plus 2. Okay, you have plus 2 as p approaches -2. And that means this one you can simply, because the limitable continuous function at the point is just its value there, you can write it as the square root of 1 plus, you have there p is replaced by -2, square root of -2 plus 2. Or if you make use of your complex number, this can be rewritten as the square root of 1 plus square root of 2i squared, okay, plus 2, or that's the same as the square root of 1, 2i squared. This is multiplication there. So plus, you have I, you can subtract the square root of I squared, square root of 2 plus 2. So this is an answer, and you can actually try to find out that these two are actually the same. So you can have this answer, or if you directly substitute, you come up with this one. But if you take a look, this one is a simpler answer because we already have simplified it first. Okay, so we'll end up with that one. So those are the odd numbered exercises on limits and continuity part 1.